is clear and you find the constellation Orion, the hunter, the one every culture on Earth has ever named. Look to the upper left, to his shoulder. There is a star there, reddish, slightly unsteady, burning with a color that does not quite match the stars around it. You have seen it 1,000 times. You have never known what it actually is. That star is called Betelgeuse, and it is dying. Not in 1,000,000 years, not in 1,000, possibly in our lifetime. And when it goes, nothing in the night sky will ever look the same again. Before we talk about what is happening to Betelgeuse, you need to understand what Betelgeuse actually is, because the scale of it does not compute at first. You have to sit with it. Our Sun is enormous. 1,300,000 Earths fit inside it. Betelgeuse is not like our Sun. Betelgeuse is 700 times wider. Its volume is 400 million times greater. If our Sun were the size of a golf ball, Betelgeuse would be the size of a house. The light reaching your eyes right now left Betelgeuse in the year 1375, before Shakespeare was born, before Columbus sailed, when the Black Death was still reshaping Europe. You are not seeing it as it is. You are seeing it as it was, 650 years ago. What is happening to it right now, at this exact second, we cannot know. We are watching the past and calling it the present. Betelgeuse is not a recent discovery. Humanity has been watching this star for as long as humanity has been watching anything. Its name comes from Arabic, from the medieval Islamic astronomical tradition that preserved and extended the knowledge of the Greeks. The original Arabic phrase was Ibt al-Jawza, meaning the armpit of Orion, the Great One, the central figure of the hunter. Over centuries of translation, the first letter was misread, the meaning got garbled, and the word shifted until it became what we call it today. Betelgeuse, the name of a star that billions of people recognize, and almost nobody knows the origin of. Ancient Egyptian astronomers tracked it. Polynesian navigators used it to cross the Pacific before Europe knew the Pacific existed. Chinese astronomers recorded it. Medieval Europeans steered ships by it. Every civilization that looked up at Orion saw that red star in his shoulder and marked it, not because they knew what it was, but because it looked different, because it seemed to breathe. They were right to notice. The breathing was real. Betelgeuse pulses, expanding and contracting over hundreds of days. A heartbeat so vast it takes longer than a human pregnancy to complete a single cycle. For thousands of years, that heartbeat was steady, until it wasn't.
It's dropping faster.
In November 2019, astronomers noticed something wrong.
Confirming signal loss.
Betelgeuse was getting dimmer, not by a small amount, not within normal variation. By February 2020, it had lost 60% of its brightness. 60%. The internet noticed. Astronomers noticed. For the first time in a generation, the question spread from observatories into living rooms and dinner tables. Was this it? Was Betelgeuse about to explode? The answer, when it finally came, was stranger than a supernova. Betelgeuse had ejected a piece of itself. A surface mass ejection, something never observed in a normal star before, had blasted material off the face of the star with a force 400 billion times greater than the largest solar eruption ever recorded from our own Sun. 400 billion times. That material cooled as it traveled outward. It condensed into dust, a veil of Betelgeuse's own shed skin, that drifted between the star and Earth and blocked the light. The great dimming was not a star about to die. It was a star bleeding. By late 2020, the brightness returned, the dust dispersed. Scientists exhaled. But something had changed. The star's rhythm, the steady, pulsing heartbeat it had maintained for as long as we had been watching, had shifted. Something deep inside Betelgeuse had been knocked loose by the violence of that ejection. And in early 2024, it began to dim again. Not as dramatically, but unmistakably. Something had changed inside it. And nobody knew what. For decades, astronomers had noticed something else about Betelgeuse, a second rhythm in its brightness, a long, slow cycle of around 6 years that did not match any known stellar process. Nobody could explain it. In July 2025, the Gemini North Telescope atop Mauna Kea in Hawaii captured something that had never been seen before: a companion star, orbiting inside Betelgeuse's own outer atmosphere. So close, so faint, so completely swallowed by the dying giant's glow that it had hidden there for the entire history of modern astronomy. Hundreds of years of observation, every telescope ever pointed at Orion's shoulder, and nobody had seen it. Scientists gave it a nickname immediately: Betelbuddy. Betelbuddy is approximately 1.5 times the mass of our Sun, a younger, hotter star, orbiting so deep inside Betelgeuse's extended atmosphere that it is essentially swimming inside the dying giant itself. It explains the 6-year cycle. It explains anomalies in Betelgeuse's behavior that had gone unresolved for decades. It had been there all along, hiding in plain sight. But Betelbuddy also changed the timeline. If Betelgeuse's behavior has been partially driven by its companion, then the internal collapse may be less advanced than previously thought. Some models now suggest the explosion could be hundreds of thousands of years away. But a separate study, focused on the nuclear burning happening inside the star's core, reached a different conclusion entirely: that the silicon burning phase may already be underway, that the iron core is already building, that the timescale is not thousands of years, but tens. 2 conclusions, both from serious institutions, both based on real data, pointing in opposite directions. The star is keeping its secret. For most of its life, Betelgeuse burned hydrogen, the simplest fuel in the universe, fusing it into helium in its core. That fusion released energy. That energy pushed outward. Gravity pulled inward. For millions of years, those two forces held each other in perfect equilibrium. Then, the hydrogen ran out. The core contracted. Temperatures rose, and the star began burning the next available fuel. Helium into carbon, carbon into neon, neon into oxygen, oxygen into silicon. Each fuel burns faster than the last, each phase shorter than the one before. Right now, inside Betelgeuse, silicon may be fusing into iron. Iron is the end. Iron cannot be fused. It absorbs energy rather than releasing it. The moment an iron core builds up inside a dying star, there is nothing left to push back against gravity. The core collapses in a fraction of a second. The outer layers, all 700 solar widths of them, fall inward at 1/4 of the speed of light. They hit the collapsing core, released in seconds. But here is what most people do not know. Before the light, before the explosion is visible to any human eye, before a single photon breaks free of the dying star, a burst of neutrinos escapes. Neutrinos are particles so small they pass through matter as if it does not exist. When SN 1987A exploded 160,000 light-years away, neutrino detectors on Earth registered the burst 3 hours before anyone saw any light. Scientists built a response to this. It is called SNEWS, the Supernova Early Warning System, a global network of detectors, including IceCube, buried beneath a cubic kilometer of Antarctic ice, watching the sky right now for exactly this signal. The moment Betelgeuse begins to collapse, before it is visible, those detectors will fire. An automated alert will go to astronomers around the world. And for the first time in human history, we will know a supernova is coming before we can see it. 12 hours, possibly, of knowing, of pointing every telescope on Earth and in orbit directly at Orion's shoulder, of watching and recording every second of the most violent event the human eye has ever witnessed. In the year 1054 AD, less than 1,000 years ago, a star exploded close enough that astronomers in China and Arabia recorded it in writing. Visible in broad daylight for 23 consecutive days, at night it cast shadows. The remnant of that explosion is still visible today. We call it the Crab Nebula. It is what a dead star looks like from the outside. When Betelgeuse goes, it will be that, multiplied. For weeks, possibly months, a new object will dominate the night sky, as bright as the full moon, visible in broad daylight, casting shadows at night. Every human being on Earth will see it. No telescope required, no specialist knowledge, just eyes. And it will be completely safe. Betelgeuse is 650 light-years away. The radiation, the shock wave, the neutrino burst, none of it reaches Earth with enough force to cause harm. It will be the most spectacular thing any living human has ever seen. And it will be safe to watch with naked eyes. 8.5 million years of stellar life, gone in an afternoon. A nebula will bloom in the shoulder of Orion, like a wound that never closes. The carbon in that nebula may eventually become planets. Some of it may become life. And at the center of that nebula, something will remain. Either a neutron star, the collapsed core of Betelgeuse compressed to the size of a city, spinning hundreds of times per second, or a black hole. Betelgeuse sits right on the mass boundary between those two outcomes. We do not know which one it will leave behind. We will not know until it happens. A star that has burned for 8.5 million years. And even in death, it will not give up its last secret easily. Look up tonight. Find Orion. Find the reddish star at his shoulder. The light you are seeing left that star in the year 1375. It has been traveling through nothing for 650 years, since before your country existed in its current form. Since before your language was the language you speak now. Thousands of generations looked up at that same star and saw the same reddish glow. They named it. They navigated by it. They told stories about it. None of them knew what it was. We do. And somewhere between that star and the retina of your eye, the truth of what Betelgeuse is right now is still traveling toward us. It may already be gone. The explosion may have already happened. The neutrino burst already raced past us in the night without anyone noticing, and the light is still crossing the darkness between there and here. Or it may still be burning, pulsing, dimming, brightening. Betelbuddy swimming silent inside its atmosphere. The iron core still building, slowly, quietly, inevitably. We don't know. Nobody does. But the next time you look up at Orion and you find that red, unsteady point of light in his shoulder, remember what it actually is: a star 700 times wider than our sun. watched by every civilization that ever looked at the sky, hiding a companion inside its own atmosphere, keeping its last secret. And remember that you might be the generation, the first generation in all of human history, that gets to see it. Go.